Hey, we're looking at properties of exponents. Right now we're going to talk about quotient of powers. All right, quotient, remember, is the answer to division. Here is our rule. So if we have a to the m divided by a to the n, then I can subtract, right? So there it is. And in our star chart, it's boom, right there. You don't have to memorize it, but if you don't know what it means, it doesn't help you. So let's look at what this means. All right, so I have a to the m divided by a to the n. So we have to have the same base. That is the first thing that has to be true for me to use this rule. My base here is a, my base here is a, same base, woohoo! If the bases are the same, I can subtract, dramatic pause, subtract the exponents. Okay, same base divided, I can subtract those exponents. Remember that this means our fraction bar is division. Every fraction is a division problem. All right, so with that in mind, here is our proof why. If I have 3 to the 5th power and 3 to the 3rd, I have the same base being divided. Okay, if I expand it, I love doing expansion. It gives me a really cool visual. So 3 to the 5th is 3 times itself 5 times, 1, 2, 3, 4, 5. And 3 to the 3rd is 3 times itself 3 times, 1, 2, 3. Awesome. Okay, so if we think about things that we know, anything divided by itself is 1. So 3 divided by 3 is 1. 3 divided by 3 is 1. 3 divided by 3 is 1. So those all reduce to 1. Woo! Okay, look at all those. What am I left with? I have a 3 here times a 3 here, so I am left with 3 squared. Now remember, the rule up here says that if I have the same bases, I can subtract those exponents. So let's go back to our exponents here. At 5 and 3, well, 5 minus 3 equals the 2, right? So the expansion helps prove it. The squared, hey, there we go. That's how we get it, 5 minus 3 using the rule. So let's try it a few times. Okay, here we go. What if the base is a variable? Remember, you can still expand just like we were doing. So example A says x squared divided by x cubed. If I expand that, so I have x squared, so x times itself, divided by, and then I have x cubed, which means x times itself 1, 2, 3 times. Okay, and then we're looking for what can I reduce to 1. So x divided by x is 1, x divided by x is 1. Interesting. What do we have? We have 1 times 1, so our numerator is 1, and we're left with an x in the denominator. Okay, so I have 1 over x is what I'm left with. This, if I were to subtract, right, same base says that I can subtract the exponents. That would be x to the 2 minus 3, which equals x to the negative 1. But we're going to learn in another video why these two are equivalent. But right now we can prove it with our expanded form over here when we look at our x's and what divides right there. Okay, so keep that in mind. I also want you to notice when we're doing this, we're doing subtraction, but I want you guys to think subtraction is the difference between two numbers. We're always going to end up with your variable, your base is going to end up wherever you have the higher exponent. So in our first example, we have squared and we have cubed. Cubed was larger, so we ended up with x in the denominator. So keep that in mind. Let's look again. We're going to do expansion again just so that we can keep seeing this. X to the 4th times y cubed. So I'm going to expand x. So x to the 4th means x times itself 4 times. And then we have y to the 3rd, so times y times y times y 3 times. Okay, And in our denominator, we have x cubed, so x times x times x. And then we have times y. All right, so let's think really quick. Where do I have more? Where do I have the higher exponent for x's? I have it in the numerator, so I should end up with an x up here, right? So let's see, x divided by x is 1, x divided by x is 1, x divided by x is 1. There's an x. All right, if I look at my y's, where's the higher exponent? Remember, if I don't see it, it's 1. So y cubed is 3 is the higher exponent than 1. So I should end up with y's in the numerator. So y divided by y is 1. And I have this y times y. Okay. So simplified, I'm left with x times, and then I have y twice. So it's y squared, y times itself twice. Okay. If we were to look at those exponents, we have 4 minus 3. 4 minus 3 gives us the 1. And then we have 3 minus 1 gives us the 2. All right, so that's what we're looking at. Let's go ahead and do this using the rule. Okay, so we have d cubed times g to the 4th times h divided by d squared times g to the 3rd. All right, so we're going to look for like bases because I can only use my rule with like bases. So first ones I see are these d's. Okay, so I have d, and then I subtract. Always start with the numerator and then subtract the denominator. So I have cubed minus the 2 for my d's. Then I'm going to look for another like base. So I have g's. Okay, cool. Let's go with those. I'm going to put my base and then subtract numerator exponent. So 4 minus, and then my denominator is 3. And then I look next. I just have this lonely h up in the top. And there's my h. Okay, so let's look at this. D to the 3 minus 2. 3 minus 2. Let me see if I can get the right color to show up. D, 3 minus 2 is 1. Okay, and then we're going to have G. G, 4 minus 3 is 1. And then we have H. And that should be my simplified version. Okay, look, I had more D's in the numerator. I had more G's in the numerator, and I had my only H in the numerator. Right, so keep that in mind. Where I have more, the higher exponent is where I should end up. All of these are in the numerator. Looks pretty good. We're going to look at how we can further check that in just a moment. All right, so here we go again. So look for like bases. They have to be the same. So let's start with H. So I have H. Where is the higher exponent? Is 3 or negative 5 a higher number? 3 is, so I should end up with a numerator h, right? So 3 minus, and don't freak out over this negative. I know that my formula says minus whatever the denominator is, so minus negative 5. Okay, and then I have this a to the negative 3rd and a to the negative 4th like bases. So I have my base, take the numerator, negative 3, minus, always tell yourself minus, and then write the next one, minus negative 4. Because notice it's not negative 3 minus 4, it's minus negative 4. That's a huge, massive difference. And we don't want to get confused. All right, so we're going to simplify this. So I know I have H, and then I'm looking here. Double negative is actually the same as adding, so 3 plus 5 should give me positive 8. And then with my A, oh, I want to switch colors for me, guys. So my A, I have negative 3 minus negative 4, so that's actually plus 4. Negative 3 plus 4 is 1, so I should have h to the 8 times A. All right, so you have a calculator, like double check your mathematics there. If you're uncomfortable with those double negatives, just quickly type it in, woohoo, check it, see what happens. All right, let's look at one more. Here we go. Same bases, y to the 4th divided by y squared. So I have y, and I'm going to approach it a little different this time. Where do I have the higher numerator? The higher exponent is in the numerator, so 4 is higher than 2. Ask yourself, how far away, how much higher is 4 than 2? It's 2, so I should end up with 2. We'll come back and verify. Okay. All right. I'm going to look at these e's, same base. Okay, so I'm looking at e. Where do I have the higher value? -2 or -3? -2 is higher, it's closer to 0, so it's a higher value. So I'm going to have -2. How far is -2 from -3? It's 1 away. Okay, and then if I look at my last one here, my t's, so I have t, and then I have 4, and I have 1. 4 is higher. How much higher? It's 3 higher, right? So this should be y squared times e times t to the third, right? And again, here, if you were confused by that, how much higher? So this is 4 minus 2 gives me 2. And then I had -2 minus -3 would be 1. And then here, 4 minus 1 gives me 3. Okay, so that's how you do quotient of powers. Just keep in mind that double negative, always write the numerator minus and then write the next term, okay, so that you don't drop any signs. They matter a whole lot. Let's see what you can do.